Hello everyone, my name is Dan the Tutor, and welcome to Lesson 7 of the free summer courses in geometry. Today we're going to be talking about polygons and quadrilaterals. This is going to be significantly easier than what we were doing last week with proofs, but of course we're going to have a whole new set of equations we're going to memorize. Honestly, today is one of the easiest lessons, so sit back and enjoy. And hey, we've only got 2 lessons left. This one and then week 8, and then that's going to be it for this summer. So, with angles and polygons, basically first I need to tell you what a polygon is. A polygon is any shape that has straight sides. Let me just give you some examples of things that are not polygons. For instance, the circle is not a polygon because it has rounded edges. Even this shape right here that I'm going to just make up that looks something like this, this is not a polygon either because of, again, that rounded edge I just made. So obviously rounded edges are a no-go for polygons. The other thing that polygons do not do, they do not have intersecting lines. So for instance, this shape that I just drew, this hourglass shape, this is not a polygon because it has intersecting lines. So polygons come in all shapes and sizes. You probably know them as triangles, squares, pentagons, hexagons, but technically it can be any shape. It doesn't have to be a perfect square, it doesn't have to be a perfect pentagon. It can even be something that looks crazy like this. This is technically a polygon because all the sides are straight and no lines are intersecting. So therefore it's a polygon. And as soon as I say it's a polygon, they have this special property that I can find the angles, what they add up to, for any shape I want. Let me give you some examples. Obviously this is a triangle. It has 3 sides. And we know that all triangles, regardless of their shape or size, are going to have 180 degrees in them. All of them. They add up to 180. Then for the square that has 4 sides, whether you knew this or not, all the angles in a square or anything with 4 sides is always going to add up to 360 degrees. By the way, I'm saying 3 sides and 4 sides and 5 sides, etc. Keep in mind it's the same thing as 3 sides, 3 angles, 4 sides, 4 angles. The number of sides will always match the number of angles. And then next, for 5 sides, you got the pentagon. This is going to be 540 degrees. In other words, maybe you start to recognize the pattern here. It seems like each time it goes up by 180. So as a matter of fact, for the hexagon, you'd expect another 180, giving you 720 degrees. But this is an octagon, which has 8 sides. So can anyone guess as to what that degrees will be?
What's 180 times 3?
And that's basically the idea here. If you plug this in a calculator, you'll get 1080. And now it's time to give you the actual formula. The degrees for angles, let me say it again. All the angles in a polygon add up to, I'm going to say total degrees equals 180 times n minus 2, where n is the number of sides, or again angles technically, but it's easier to count sides than angles, but it's the same number. So any questions on any of that? Okay, then for instance, I can go about this shape, even though it's a trapezoid. We say it has 4 sides, so immediately I can find the total number of degrees. I'll call it capital D for degrees. It's going to be 180 times n minus 2, so 4 minus 2. So 180 times 2, that's going to give you 360 degrees. Like I said before, any shape with 4 sides automatically is going to have 360 degrees. Now, the next page, it looks like we have a hexagon. A hexagon, obviously 6 sides. And so I'm going to say D, the total number of degrees, equals 180 times 6 minus 2. That's going to be 180 times 4. And 180 times 4 just happens to be 720 degrees. Now, here's a question. What do you think the degrees will be for this one? Well, first of all, how many sides does it have? 1, 2, 3, 4, 5. It's got 5 sides. So that means the total number of degrees must be 180 times 5 minus 2, which is equal to 180 times 3. And you plug that in the calculator, and you'll get 540 degrees. In other words, the same exact number of degrees as a regular sized pentagon. Both of these shapes have 540 degrees. Even though one looks crazy, it's still going to be 540 degrees. Now there are these special kind of polygons we call regular polygons. Regular polygons are the polygons you're thinking of. In other words, they're the symmetrical ones. I called them perfect earlier, like a perfect square, a perfect pentagon, a perfect hexagon. They are technically called regular polygons. So for instance, a regular square, a regular pentagon, a regular hexagon, etc. Now, regular polygons are polygons where all the sides, and I know I missed it here, and angles are equal. All the sides and all the angles are equal. So as you can see here in this hexagon, they're all going to be 120 degrees. But in case you're wondering, where did I get that 120 number? I didn't just make it up. We have another formula to memorize. So first we said the total angle equals 180 times n minus 2. Now I'm going to say each angle is equal to the total angle divided by n. And this makes perfect sense because if you have a total of, let's say, 720 degrees, and you want to share your pi between 6 angles, 720 divided by 6, everyone's shared equally, you get 120. But don't just take my word for it. Let's actually do the math. So d, the total number of degrees, equals 180 times 6 minus 2. We actually already did this today. You get 720 degrees. And then what I'm saying is each angle is going to equal the total angle, 720, divided by the number of sides, which is 6. And you plug that in your calculator and you get 120 degrees. And that's exactly what I was saying above. That the hexagon, each angle has 120 degrees. So are there any questions on that page? Okay, so then that means we're now going to look at a few quick examples. Find the measure of each angle in the regular polygons. So first you have the triangle. We already said it has 3 sides, and we already know the total number of degrees is 180. We already know that. Then if you want to find each angle, it's just going to be the total degrees divided by the number of sides, 3. 180 divided by 3 is just 60, so 60 degrees. And so what that means is every angle on this triangle is going to be equal. They're all 60 degrees. And maybe you already knew this because this is called the equilateral triangle. In other words, an equilateral triangle is a regular polygon or a regular triangle. And they're all 60 degrees. Next we have, how many sides is this? 1, 2, 3, 4, 5, 6, 7. 7 sides. I think it's called a heptagon. So what that means is that the total degrees equals 180 times 7 minus 2, or 180 times 5. You plug that in a calculator, you get 900. And then again, if you want to know each degree, then you're just going to do 900 divided by 7 sides. You're going to get a decimal. You're going to get 128.6 approximately. And so then again, each one of these angles is going to be 128.6 degrees all the way around, adding up to a total of 900. Any questions on any of those? Okay then. So now, I'm not gonna lie, this is gonna be a really short lesson. We're literally already halfway done and we're like 10 minutes in, which is wild. I wasn't kidding when I said this one was easy. But if you think about it, the last 2 lessons were really hard. So this is averaging out to like a normal lesson, I guess you could say. Anyways, the next thing we're gonna talk about is quadrilaterals. Quadrilateral is just a fancy word for 4 sides. These are going to be shapes, specifically polygons, that have 4 sides. And as you can oh, that was the fill in the blank right here, actually. Yeah. So, as you can see here, here's some of our best friends in the quadrilateral family. You probably know some of these guys by name. For instance, from left to right, we have the square, and then the rectangle. Who knows what the shape in the middle is called?
Rhombus.
Rhombus is correct. Here's a question for you guys. Does anyone know what's special about a rhombus? Like, obviously, it's you know what a rhombus looks like, so you at least have an idea. Can anyone describe what the special thing about a rhombus is?
It's like a jewelry.
It does look like a jewel, I will agree with that, but that's not what you're going to find in the official math dictionary. We'll talk about it later today. Don't worry. This shape... Go ahead.
Does it have to do with like triangles?
Kind of. You can make an argument that it has to do with triangles, but that's not the explanation I'm going to give today. But thank you for thinking, because it's fun to think. Anyways, this one's easy. It's the trapezoid. I'm not even going to question your intelligence with that. But what about the last one?
The parallelogram.
It is a parallelogram. What's special about a parallelogram?
That I have no idea.
Oh, yes, you do, because you clearly knew what it looked like.
Yes, because it has a slight. It looks like a rectangle, but it's slightly bent.
Do you know what the key word in parallelogram is?
Parallel.
Yes. No, just kidding. It's gram. Yeah, of course, it's parallel. Yeah, so basically, parallelograms are shapes that have two sets of parallel sides. So, call me crazy, but I would say the square is a parallelogram because this side's parallel to that side, and this side's parallel to that side. And you can say the exact same thing for the rectangle and the rhombus, too. Those are parallelograms. The trapezoid is obviously not a parallelogram because these sides are not parallel. But here's the thing I want you to know today. That just because I call it a square means that it can have different labels as well. As a matter of fact, you've probably heard at some point in your math life, I mean maybe you haven't, but I'm going to tell you right now, that squares are technically rectangles, but not all rectangles are squares. Another thing I could say is all squares are rhombuses, but not all rhombuses are squares. And all squares and all rectangles and all rhombuses, rhombi, I don't know how you'd say the plural, but all of them are parallelograms. And none of these four shapes are ever trapezoids, because trapezoids only have one pair of parallel sides. And that's basically what we're going to be talking about today, is we're going to talk about these relationships and what makes each of these geometric shapes so special. So, let's start with the square, our favorite. So we all know what a square looks like. You probably already know that all the angles are 90 degrees and all the sides are equal. And also we just said earlier that all sides are parallel. All of this is true. And as a matter of fact, if I was to label the square, I would first say that it has four 90-degree angles, which makes them right angles. And I know all the sides are equal to each other, so instead of saying like a length times a width, typically we just say every side has length S, which stands for side. Now let's talk about the area and the perimeter. Just out of curiosity, who knows the area of a square equation?
You mean the area, like all four sides are being summed up?
No, that's the perimeter. But you can tell me the perimeter too.
Isn't like side squared?
Yeah, area is side squared. And then how about perimeter?
All four sides are added up to one.
Yeah, so what would it be? How would I simplify that? Like you're saying it's S plus S plus S plus S, you're right. But how would that simplify?
4S?
Exactly. Yes.
4.
And so, by the way, by the time we're done talking about just the area of a square and a rectangle, you will officially be smarter than most of my college students. And you may be wondering, why do I say that? It's because literally, in calculus, there's a point where you have to remember the area of a rectangle. I think 50% of my students remember the area of a rectangle. I don't know how they got into college. I wish I was joking. So, with rectangles, it's very similar. All angles are 90 degrees, and all the sides are parallel. They are not equal, but they are parallel. So in other words, we've got right angle, right angle, right angle, right angle, and then usually for rectangles we say length and width. You can also say base and height, but I'm going to go with length and width today. Using the same logic as before, what's the area and perimeter? Let's start with area. What's the area of a rectangle?
Length times width.
Length times width is correct. And then how about the perimeter?
Two sides add up, right?
And what would you say that is?
Length plus width plus width.
And how would you write that more simply?
Length squared plus width squared.
Close. It's not squared, it's times 2. It would be squared if you were multiplying, but since we're adding, it's just 2 times. Now, by the way, even you saying length plus width, again, I've been doing this a long time. I think I've had one student ever. I've tutored at least 100 kids in calculus over the past 3 years. One student knew the perimeter of a rectangle. And you have not even taken geometry yet. Like, you haven't even learned this, but you remember it from grade school. It drives me crazy. And it's like, it's calculus, right? I assume you know how to do the basic stuff. And they don't. And it makes me upset every time. But that's the life I chose as a tutor. So that's what I have to deal with. Anyways, the rhombus. As I alluded to earlier, the rhombus, what makes a rhombus special? I don't know if you knew this or not, but all sides are equal for a rhombus. It may not look like it because it's slanted weird, but all the sides are equal. For instance, I can call this S, 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 and S. And also, all sides are parallel. Like we said before, that's why rhombuses are also parallelograms. And finally, there's one more blank. Something else is equal. It's the opposite angles. The opposite angles are equal. So for instance, if I have this angle is congruent to that angle, I have this angle is congruent to that angle. And of course you can say like definition of a rhombus if you want to, and if you're doing a proof, you can use that as one of your reasons. But we're not talking about proofs for the rest of the summer, so yay. And now you're not going to ever find the area of a rhombus, but we can find the perimeter. How would I find the perimeter? It's just going to be all the... Go ahead.
All S's combined into 4 S's, right?
Thank you. Yes, that's correct. 4S. Yep. S plus S plus S plus S, 4S. Now the trapezoid. We all know what's special about the trapezoid. It's probably one of the most recognizable shapes out there. It's got only one pair of parallel sides. And now, I don't know if you knew this or not, but there is an area formula for a trapezoid, and it follows the following. First, when I was your age, basically what I did was I broke this up into 2 triangles and then like a rectangle in the middle. And you can still do that. But basically there's a shortcut formula. It's if you call this top one base 1 and the bottom one base 2, and you call the height, let's just say h. First, I'll ask the audience, does anyone know the area of a trapezoid? I'm expecting no.
I just did the triangle thing.
Well, I did too, to be honest. But I think it's handy to know.
But it's a triangle, they're rectangles.
Let me show you. Basically, what I'm saying is you can break it up into 2 triangles.
2 triangles and a square.
In this case, it looks like a square, but it's technically a rectangle. But yes, you get it. Either way, there's a shortcut formula I'm going to teach you today. You don't have to memorize it because who wants to memorize something in math? But if you do bother memorizing it, it's not bad at all. It's 1/2 base 1 plus base 2 times the height. 1/2 times base 1 plus base 2 times the height. So that's an easy formula. And then the last one on this page is the parallelogram. Parallelogram, obviously 2 pairs of parallel sides. And then if I tell you the base is just b, and the height, not across the diagonal, the slant, but just straight up and down is height, the area of a parallelogram is just base times height. I would say length times width, but length and width is specifically for a rectangle. It's technically not true to call it that for a parallelogram, so I call it base and height. Any questions on any of those? Oh, okay then. So on the next page, we're just going to be talking about finding the area and perimeter of the shapes. So for instance, with A, we have what shape is this? It's a rectangle.
It's
Yep.
a rectangle, yes.
It's a rectangle. And so then the area is just going to be 12 times 6, length times width. And that's
You're
just going to be
rushing,
72.
Al.
What'd you say?
You're kind of rushing,
Okay, sorry, I'll slow down.
and I can't keep up. I kind of missed some of the information.
Well, I apologize. By the way, if I'm ever going too fast and you miss anything, you can also either stick around for the end and I can answer any questions, or you can also watch the recording. So don't worry about missing anything. You won't miss nothing. And then for the perimeter, it's going to be 2 times the length, 2 times 12, plus 2 times the width, 2 times 6. 2 times 12 is 24, plus 2 times 6 is 12. 24 plus 12 is 36. Any questions on that first one? Okay. So then now with part B, what shape is this? This is going to be a square. How do I know it's a square? Because all the sides are equal to each other because of my
All
tick
the
marks.
sides are equal. It's a shorter rectangle.
Yeah, you can think of it like that too. Now, I think you know how to do it for the square, so I'm going to give you 30 seconds, maybe 45. Go ahead and find the area and the perimeter of a square. And then if you're watching the recording, just unpause the video and we'll check our work. Okay, I'm going to say time's up. If you didn't finish, that's okay. But here's the solution. Here, first, we're going to say the area is equal to side squared. So 7 squared is 49. And then the perimeter is just 4 times the side, 7. So the perimeter is 28. And a lot of times in math, we do have units for these. And obviously, I don't have units here. And that's just because it doesn't matter that much. What's more important, obviously, is the formula. Next, for part C, we have the area only. And this shape is obviously the trapezoid. So now we get to practice our formula with the trapezoid. So for instance, the area is going to be 1/2 times base 1, which I'll say is 5, plus base 2, which I'll call 10. The order doesn't matter, by the way. You can mix those up. Doesn't matter. And then times the height, which is 8. So then 1/2 times 5 plus 10 is 15, times 8. And if you plug this in a calculator, you're going to get 60, and 60 is your area. By the way, how would you even solve this one with the triangle method? It wouldn't work, would it? Because I don't know, like 10 is the whole base. I don't know the base of each of these triangles. So even if I wanted to use that method, it wouldn't work. So you have to use the formula this time.
Wouldn't it be 2.5?
What would be 2.5?
The base of the triangles?
Yeah, I guess that would be assuming this is... Yeah, I see what you're saying. You're saying that 5 minus 10 is 5, and the 5 is split up halfway between 2.5 and 2.5. And here's an interesting thing, actually. I'm going to say, yes, you're right, and you're also wrong. But let me explain why, because you bring up an interesting point. You don't know that this is a perfect trapezoid. In other words, this could hypothetically... Let me just show you 2 trapezoids it could also be. For instance, it could be 5 up here, 10 down here for the whole side. And then, for instance, it could be split up. Let's say this is 2, and let's say that's 3. Like, that's also technically possible. I didn't have to draw it perfectly centered. Now, as it turns out, the math actually comes out exactly the same, so you're going to be fine either way if you do it that way. So that's why I'm not going to say you're wrong. Another thing I think that's interesting is, what would you call this shape? This is a shape you've probably never seen before. It's kind of like a trapezoid, except it's like the left side is like a rectangle.
A half trapezoid.
A half trapezoid is one guess. Any other guesses?
It's kind of like a side trapezoid.
We also have the guess of a side trapezoid. Any other guesses? The correct answer is, it's a trapezoid. And this is something that I thought was weird, but I literally learned...
Yes, it is a trapezoid.
Why?
Because because only 2 lines are parallel.
Because we only have one pair of parallel sides, and by definition, that's a trapezoid. So even though this looks like a half trapezoid, it's still called a trapezoid. And actually, this formula is actually even easier to find if you want to do it we'll call it the long way for now. But you can split up into now just one triangle and one rectangle, and you can find the area that way as well. So either way, yeah, you can find, I guess, area a lot of ways for the trapezoid. It's kind of the moral of the story. But which way do I prefer you do it? Honestly, I don't care. I just want you to do it the way that you're most comfortable with. And if that, for you, is breaking it up, I am A-okay with that. And then part D, we're going to find perimeter only for the rhombus. If we remember perimeter for the rhombus, remember what's special about the rhombus is that all the sides are equal. So it's just 18 times 4. And 18 times 4 is 72. And that's the perimeter of this rhombus. Any questions? Now, if we want to find the area of this rhombus, the correct answer is it's not possible to find it. We just don't have enough information. And it's because we don't know any of the angles. And so if you think, for instance, that it's just 18 squared because it's the same formula as a square, that's actually not necessarily true. We don't know what it is. But that's okay. We don't need to know what it is. It doesn't matter. So now in the next page, as I said before, we have all these different relationships between basically all the different shapes that I just said, squares, rectangles, whatever. Okay? And so since I have two people in the audience and we're just alternating with true and false, I'm going to basically alternate between you two in terms of the answers, if you're okay with that. And let's talk about these. So for A, Shronik, you can get letter A. I want to know if the statement is true or false. It's not sometimes true or sometimes false. It's either true or false. All squares are rectangles. True or false?
False.
Why? Give me a counterexample.
How could squares and rectangles might share relation, but
Here it is.
wait.
What's the definition of a rectangle? Two things.
Oh yeah, two lines are parallel.
Two lines are parallel, number one. And what's the other thing?
Squares.
No. What else
sides
is
are-
true for the rectangle? You said two sides are parallel. That's true. What else is true for the rectangle?
Not all angles are equal.
No, actually, rectangles, all angles are equal. They're all 90 degrees. And by definition, the square fits both of those criteria. So it is true.
Oh, it's true.
All squares are rectangles.
But rectangles aren't squares, right?
Some are. The answer is some are. And next, part B. Kira, are all rectangles squares?
No, false.
Can you tell me if any rectangles are squares? So in other words,
Are.
I agree that this is false. Can you give me an example of a rectangle that is a square?
If the rectangle, to fit the criteria, all sides have to be parallel, but if all sides are equal to each other, then they can be a square.
Yes, you're
But-
saying, yes, you're exactly right. If the rectangle has all sides are equal to each other, then it is also a square and a rectangle. Exactly.
Yeah.
So in
But
other words, go ahead.
But if the sides aren't equal to each other, but they're all still parallel, they can be a rectangle but not a square.
Exactly. You're exactly right. Now part C, back to Shronik. Some trapezoids are parallelograms. True or false?
Well, yes, they can be.
Give me an example.
Like, for parallelograms, two lines aren't only parallel, right?
Well, it's
Trapezoid-
not just two lines, it's two sets of lines. So like that guy and then the top and the bottom. Like both sets have to be parallel.
Oh, yeah. So false.
I agree, it is false. Because by definition, trapezoids only have one pair of parallel sides. And next, back to Kira. All rhombuses are squares.
False.
Can you give me an example?
I have to look at the definitions. Give me a second.
Take your time.
I think it actually might be true.
Okay, and that's because?
It says. Oh wait, no, it's false. Because all sides are equal, but they could be at a different angle than 90 degrees, as it's stated in the definition for squares.
So you're saying that this is a rhombus because it is all the sides are equal. But let's
Yeah.
say the angles are different. Let's say this is like 100 degrees and that's 100 degrees. But then that's, I have to actually think, that's 80 degrees and that's 80 degrees. And because they're different, it's no longer a square. That's what you're saying?
Yeah.
You're exactly right. False. And of course, you could make that statement D correct if you change the word all to some. Now, answer choice E, not answer choice E, question E, all parallelograms are rectangles. True or false?
Wait, what?
All parallelograms are rectangles.
Rectangles only have one parallel.
No, rectangles have two pairs.
Oh yeah, they're true. Oh yeah, it's true. It's true.
It's false. The reason why is because let me show you a parallelogram that is
Oh,
not a
no.
rectangle. Here's a parallelogram because, again,
Oh yeah, because the angles are different.
yes, the
And
angles are
it's not.
different. Exactly. So false.
Rectangles have right angles.
Rectangles
So-
must have 4 right angles, exactly. And parallelograms don't need them. Next, part F. All rhombuses are parallelograms.
Yes, I think that's true.
Why?
Because in the parallelogram definition, it says to be a parallelogram, you only need two pairs of parallel sides.
Mm-hmm.
And in a rhombus definition, it says all sides are equal.
Yep.
Or
And
no, it says all sides are parallel. So
Yes.
that would mean
That's-
two pairs of parallel.
exactly. So because rhombus fits the definition of parallelogram, it is true. And then finally, part G. All squares are trapezoids.
No, they're not.
I don't even
Oh.
know why I put this here. I think I meant to write some, because that would at least make
No,
some
they're
sense.
not. They're
Still
not.
no. I agree. Still false. Because squares have 2 sets of parallel sides, trapezoids do not. I don't know why I put all. That is like the most obvious one out of all these. Okay. So very good, guys. That was fun. You really got some mental juices flowing there. And now I believe this is the last page today. We're just going to be using the facts that we just learned to solve some, variables and some equations here. So for instance, part A, I tell you it's a square. This side's 13 and this side's x plus 3. And I want to solve for x. How am I going to do that? So basically I'm going to use the fact
They're
that...
both equal.
Go ahead.
They're both equal, like they're parallel, right?
Yeah, parallel and equal are not the same thing, but I agree with equal. For a square, all the sides are equal. And so therefore 13 must equal x plus 3. And so that means subtract 3 from both sides, 10 equals x. And there you go, you're done. You solved for x, x is 10. Now for part B, we have the rectangle. For the rectangle, you can see here I have an arrow pointing to that right angle, saying 2x plus 40. How am I going to find that angle, or x?
90 equals 2x plus 40
Exactly. And why does it equal 90?
because 90 is the degree of the angle.
Yeah, because right angles are 90 degrees. Exactly. You get it. Now, actually solving for x, this is, I guess the hard part, but even that's not that hard. Minus 40 from both sides, 50 equals 2x. And then you just divide both sides by 2. And we'll get x equals 25. You could say 25 degrees, it doesn't really matter. But there we go. Any questions on that one? Okay. Why don't you try the next one on your own? C, parallelogram. Don't do D yet. We're going to first talk about C first. So go ahead. Okay, I'm going to say time's up. If you didn't finish, that's okay. So basically, because this parallelogram has 2 opposite angles being equal to each other, and I know we actually didn't say that in one of our properties. I forgot to mention that. But yes, for parallelograms, the opposite angles are going to be equal to each other. So 48 is equal to 63 minus 5x. And now it's just a matter of solving for x. So first, I'll subtract 63 from both sides. This is some pretty difficult mental math, I'm not going to lie. But you get negative 15 equals negative 5x. And then you divide both sides by negative 5. We'll get x equals now positive 3. And then there's only one more left. It's the rhombus. Now, I'm going to do this one with you guys because this one I think is too hard to do on your own. Although maybe you'll get it and then you prove me wrong. But any ideas on how I'm going to solve for x here? Because I'm not... You already got it?
Yeah.
Let's hear it.
I got x equals 60 because since rhombi, I don't know, they have
Rhomboheli. Go ahead.
the opposite angles are equal to each other. So the bottom one would be 120.
Mm-hmm.
And since it has 4 sides, I believe it has to equal 360 degrees.
So you're calling back what I said earlier. Very good.
Yeah. So 120 times 2 would be 240. Subtract that, you get 120.
And why are we subtracting it, just to be clear?
To find out like what is
You're saying
left.
the remaining angle, exactly.
Yeah, the remaining two angles would equal 120.
Yes.
So you divide that by 2 and you get x equals 60.
Exactly. And we're dividing by 2 because we have basically shared between two angles left. And they have to split them up equally. So, 120 over 2 equals x. So x is 60 degrees. And by the way, another way you could do that if you wanted to, I'll just show you on a separate sheet of paper. Another way you could have done this, if this is 120 degrees and this is unknown x, one thing you can technically say is that if you remember back on our lesson about corresponding angles, actually no, we didn't talk about corresponding angles, did we? Okay, never mind. But basically what I'm going to tell you is 120 and x are technically supplementary. And you may not see why. It's because it uses a theorem we haven't talked about this summer yet. But because they're supplementary, 120 plus x must equal 180. And I know it doesn't look like they're supplementary, but just trust me, they are because of a theorem that we didn't learn about this summer. But you get x equals 60 that way as well. So I like the way you did it more, though, because you used something else we talked about earlier today, which is four-sided quadrilaterals are going to have 360 degrees total. And just like that, we're done for today. And there's only one lesson left, and it's about circles. So we spent an entire lesson today on polygons. Next week, we're gonna talk the whole time about circles. By the way, that's stuff that you talk about at the very end of the year with geometry. But, of course, it's important or else we wouldn't be going over this summer. So thank you all for joining me today. I'll see you next week, and take care and bye-bye.